The SIGEVO lecture is aimed at representing the heart of our own community. Not only that, the SIGEVO lecture is also meant to provide a sense of depth, wisdom, and a truly core experience by inviting key figures from our own field who have enough experience to look back and share with us their hard-earned insights, their values, their ideals regarding our field. The past 8 speakers were Stephanie Forrest, Hod Lipson, David Goldberg, Ingo Reichenberg, Daryl Whitley, Melanie Mitchell, Eric Goodman, and Ken de Jong. And it's my great pleasure as SIGEVO chair today to introduce that the 9th speaker to be added to this honorary list is Una Mae O'Reilly. Una Mae is a renowned researcher in our field. In 1995, she obtained her PhD in computer science from Carleton University with a thesis that is one of the world's first on the AI topic of genetic programming. She joined MIT as a member of the Artificial Intelligence Lab in 1998, and since then wrote over 150 academic papers. She is an area editor at the 3 main journals in our field and has an advisory role at the Oak Ridge National Lab Directorate Advisory Committee. Una Mae has had many research sponsorships from the National Science Foundation to Jaguar Land Rover and Philips Healthcare, showcasing the broadness of Una Mae's knowledge and the applicability of her research. She received the Evo Star Award for Outstanding Achievements in Evolutionary Computation in Europe in 2013, and very recently at this very GECCO, a SIGEVO Impact Award. Today, she is the leader of the Alpha Group at MIT CSAIL, tackling fundamental topics such as machine learning, evolutionary algorithms, and artificial adversarial intelligence, as well as applied topics such as cyber and information security. Una Mae is no stranger to GECCO or to SIGEVO. She was there for the very first GECCO in 1999, of course. But also she was general chair of GECCO in 2005 and has been vice chair of SIGEVO. She is also the initiator of Women at GECCO, hailing back to 2013, when she was getting as many people as possible to wear pink t-shirts that promoted the workshop, and of course, that included me as well. Una Mae has been a mentor to many people, and today we hope that she can mentor us all with her knowledge and wisdom inside and outside the field. Altogether, it is without a single doubt that Una Mae may be called a true figurehead of our community. It is therefore my great pleasure to ask you for a big hand to welcome to the stage our SIGEVO keynote lecturer of this year, Una Mae O'Reilly.
Thank you. Thank you. So I'm looking for my slides. That looks good. But that is not my first slide. Slides up. Thank you. Okay, well, I'm going to start by thanking Peter for that very nice introduction. And it does feel like I'm home and talking to my family here, but it also feels very nerve-wracking. And that's because I really value the opinions of all of you when I share my work with you. I have great respect for everyone here, and it's a real privilege to get to tell you about my work. And before I start, I also want to recognize 2 people very early in my academic journey. On one side, we have Professor Ian Whitten, and he took me when I was just an undergraduate, and all I was doing was getting that degree in computer science so I could work, and then I could play badminton and travel the world. And he said to me, no, you need to go to graduate school. You need to go and figure out what computer science means to you. So that was really important, and I lost Ian a couple of years ago. And on the other gentleman here on the left is Franz Opacker, and he is my PhD supervisor, and I lost him about a month ago. And Franz was integral because the very first meeting I went to about evolutionary algorithms was a workshop on genetic algorithms at IGCECCO in Sydney, Australia in 1992. And Franz took me there, and he introduced me to this. So the title of my talk today is Coevolution in Natural and Artificial Systems. And I'm not sure if any of you caught that it's actually an homage to John Holland, because John Holland wrote this book called Adaptation in Natural and Artificial Systems. And that was actually one of the books of 2 that were on my PhD comprehensive exams. And it was no trouble to read these books. This book in particular was inspiring. It explained complexity, complex systems, intelligence through nature and natural systems, and it was a pleasure to read. And so it's an honor to actually sort of narrow the scope of adaptation to coevolution and talk about coevolution in natural and artificial systems. So let's start with that. Coevolution in natural systems. So in biological systems, coevolution occurs when two or more species reciprocally affect each other's evolution through the process of Darwinian natural selection. And in particular, predator-prey coevolution is when one of those species is a predator upon another, and its evolution impacts the evolution of the prey. And what you see here is an example of predator-prey evolution that's fairly classical in the literature. If you Google it, this is the cheetah and the gazelle. The cheetah has to evolve to be faster and stronger in order to eat and survive. And the gazelle must also reciprocally evolve to be faster and stronger in order to, not be dinner or become extinct. So between this cheetah and the gazelle, and in all natural coevolutionary processes, we often see emerge a coevolutionary arms race. And that's this reflection of the process where each species is spurring the others on to becoming more and more complex and superior in terms of their competition with each other. So the evolutionary algorithm community, or the EC community, abstracts predators and preys co-evolving and calls it a coevolutionary algorithm, or a competitive coevolutionary algorithm, if we want to talk about that predator-prey coevolution. And this algorithm is really just two EAs coupled, right? One EA which tracks the evolution of a defender population, that would be the prey, and another evolutionary algorithm that tracks the evolution or drives the evolution of an attacker population. And these two evolutionary algorithms are coupled, and the way they're coupled is that we take one member out of each population and we compete that pair against each other, because we set those populations up with conflicting objectives. One might want to maximize something and the other might want to minimize something. So fitness of an individual in a coevolutionary algorithm is obtained by taking that individual out of its population and competing it against members of the adversarial population, and tracking how well it does, and either averaging that fitness, taking the best fitness, or taking the worst fitness against all that array of opponents. And that's often called a solution concept in the algorithm. But after fitness has been assigned through this interaction between the two populations and their individual members paired up, then the algorithms sort of almost independently proceed, right? There's a selection step based on fitness, there's variation, and the old population is replaced by the new population. And I generally, when I started using these, there had been a tremendous amount of earlier work preceding me establishing these algorithms. And if you pick up any paper authored by me or members of my group, you'll see those people acknowledged. But basically, this framework had emerged. So my plan today is to tell you how this gets really interesting to use these algorithms to replicate co-evolving systems that are natural or that arise in our human endeavors. And, I think all of you get really excited by evolutionary algorithms. So I hope you can bear with me. I'm going to take you through 3 case studies. And in each case study, we have studied a natural system where there's an adversarial attacker-defender relationship and an evolutionary arms race. One of those systems is the taxation system. That may strike you as odd, but with a little bit of thought, I think you can think about the evolutionary arms race there. Another is cybersecurity. And the third one is in machine learning, generative adversarial networks. So without any ado, I will proceed to case study number 1, where we tried to replicate the arms race between tax avoidance and tax auditing. We built a system called Stealth, and when I say we here, or I here, I'm actually referring to a great number of student team members, and in this particular instance, I've got Eric Hemberg sitting in the audience and others who are called out. So tax evasion actually is real, and it's important because it's not fair, right? And what happens is that there are evaders in some population, and they they create avoidance schemes. And these avoidance schemes are really sequences of transactions where they start with an asset, and every transaction transfers some part of the asset elsewhere. And because those are certain types of transactions, there's tax that goes into, it's called an asset basis that's applied to these objects, these assets that are passed. So by following a sequence of transactions, tax evaders change the tax owed on an asset. They can do it legally, but they can also do it illegally, right? And what tax auditors do is they can only observe all these different properties of these transactions. They have a small amount of resources, and they have to figure out how to allocate a small amount of resources and choose some of those observables to watch to see if they can actually detect tax evasion. And of course, when things start, it could be that the auditors are looking at the right observables and they can actually damp down the evasion. But when the evaders choose new transaction sequences that move the assets around, like a shell game, and they reduce the taxes so that they pay less, and it's kind of against the regulations, well, then the auditors are falling behind because we're looking at the wrong things. The auditors have to adjust what they're observing, the weights on what they're observing, and then they're actually able to master this. And it turns out there truly is a coevolutionary arms race documented. And it's worth $91 billion in taxes lost to the US government around the 2010s. So this is a really hairy, natural, co-evolving system. And how do you sort of wrestle with it and actually come to replicate it? That was really the exciting challenge here that I want to share with you. And you'll see that I have to solve the same problems you're solving when you try and do modeling with your evolutionary algorithm. How am I going to represent that evasive behavior? How am I going to represent auditing? Right? How do I figure out how to tax a tax sequence? What's the fitness function here? What is it that someone's trying to maximize, and the reciprocal of which someone is essentially also maximizing, right? So that's what I want to tell you about it with this taxation case study. And let's start with the phenotype. How do evaders behave? So this is the evader population, and I've alluded to them being given a portfolio of assets. And what we do is we now, with that portfolio of assets that each evader is given, we set them up to choose from a large set of transactions that they can perform, and to actually build successive sequences of these transactions so they can transfer the asset. And that means that really the transaction sequence is a sort of executable thing that we want to record, and we record it with a graph, and we actually record also the change in the asset basis on which the tax is made. So while this is going on, we also extract all the things you can observe from the transaction sequence, because the auditors are going to need that, right? But I just mentioned that you need to generate tax sequences, and you need to execute them. So what did we do? We used grammatical evolution and genetic programming, right? Grammars are generative, and genetic programming allows you to evolve generative expressions or generative sentences from a grammar. So this is our grammar for tax evasion, right? You can, and we implemented the particular actions within it, and now we can take those sentences and we can execute them and create those transaction sequences. So our tax evaders literally take an asset and move it around. All right, and we have a record of all that, so we can check two things. We need to be able to check, well, what is the basis of that asset for taxation, and what is the tax that we need to have based on that? Because then we can check on whether that's ideal or whether they've actually evaded. So the problem is, again, boy, is the tax code complicated. We thought we'd take a look at it, and one day this large box came to my office addressed to my student working on the project, and I took it to him and I said, I think I got a bomb in the mail for you. And he opened it up and he said, no, that's the US tax code. Right? the reason the tax code is so easy to take advantage of is because each section has a lot of options. And you can string together these different actions that apply to these regulations with these options. And that's where, the loopholes can get discovered. So what we had to do is simplify. A lot of times when we're replicating these real-world problems, we had to find the simplification that's still representative of the heart of the problem. Right? That's really what we all do. We abstract and model. So we were able to send our student, who had the whole tax code, off to Harvard Law School, the best law school in the country, arguably, and he studied taxation and tax law. So he could now come back and figure out, not just where the taxation loopholes were, but how we were going to actually implement taxation on transaction sequences so we could compute the tax. And he came up with a computer science implementation of that. If you want to decide how you adjust the basis of an asset based on a transaction, we have a decision tree. And then if you want to decide how you're going to tax that asset, we have another decision tree. And so we could build these decision trees, and we can take a very small slice of the tax code. And ahead of time, we knew that within it, there was potential transaction schemes that were going to avoid paying the correct amount of tax. But of course, what we wanted our evaders to do was find them and maximize that tax that they were avoiding. And what we wanted our auditors to do was completely the opposite, right? We wanted them to figure out the observables that were going to tell them that this particular transaction sequence should be audited, right? So to do that, again, we had to go back to the tax code. We had to have this domain knowledge, right? And we identified different properties of tax regulations that we could look that interacted with our transactions. We called those the observables. And we knew that there was more observables in the space of all the possible transaction sequences than we were going to give our auditors the chance to monitor. Right? So what an auditor does is it just gets a vector of all the observables, but it gets a small budget and it has to allocate them across certain ones of them. And its budget is not going to be enough to cover all of them. So our auditors are trying to come up with a score that rates the audit likelihood of an evader's transaction sequence, and it's going to be based on what they see and what emphasis they put on what they see. Okay, and so for fitness, we have a fitness function that essentially says, look, an auditor is fit if they assign a high audit score, right, to a very, very high evading scheme. And an evader is fit if they receive a low audit score, so nobody notices them, and they still evade a lot, right? They get a huge amount of non-compliancy out of their transaction sequence. And as a corollary of this, the fitness function also reflects that, an auditor is fit if they assign a low audit score to some evaders that's not doing much evasion, and the evader is not really very fit if it can't evade. Right? So that's really how the fitness function works. And we set this all up, and were we successful? Well, we were. We were able to, from our grammatical evolution attackers and our weight-based defenders, auditors and evaders, we were able to start with a population where we didn't give the auditors access to the observables that they needed to find a particular scheme. And we gave the evaders the capacity to evolve a good scheme. And sure enough, the evaders eventually found a well-known scheme. It's called IBOB. And they remained very high, and that scheme stayed as the best strategy in the population forever, because there was no way the auditors could move the weights to find observables that would find that. Right? So now to make it a little bit more complicated, we need that coevolutionary arms race. So take a look at this picture. It's got two fitness, it's sort of showing you a fitness curve for the evader, and it's showing you the phenotype of the auditor. Right? So what you see is that the best evader in the population at the beginning is pretty good. Why? Well, because the auditors don't know what to look for. They're just random. right? But over time, quickly, by generation 30, the auditors hone in on the observables that indicate that that particular best transaction sequence needs to be audited. And that drives down the fitness of that best sequence. And you can see, so the way you're seeing the auditor here is we've taken every observable and we colored it a different color. So you can see the shift in what observables are being watched by how the color shifts here. Right? And what happens though is at the right bottom, where that first bottom out of the fitness curve for the evaders, when all of a sudden the attackers, the auditors know completely what to look for, and they drive the fitness of that evader down, a new strategy emerges as the best one in the population, and it's one that's picking on the observables that the auditors aren't watching. Right? And you can see that. All of a sudden, it goes to the top, and we now have to find the observables that detect it. And that's our coevolutionary arms race, right? A moving between the predator and the prey. So the actual result, it's a funny story. It only got a poster in GECCO. But there's a lot of hope. For all of you who got posters in GECCO, 10 years later, you can have a SIGEVO keynote, okay? But it did outside the GECCO community, and I have to say, in some sense, it was legitimate, that those reviewers, because we didn't have an innovation in an coevolutionary algorithm. We used what everyone else was using. And we didn't have a real-world application because it seemed really far off from us actually getting to the point where someone would actually use this method. So you give them a poster. But when we took the work outside the community and we went to the AI and law community, well, then we won innovation prizes with evolutionary computation, right? That's Jacob accepting one. And news got around. We got attention. We got written up in the New York Times. This is a super important problem. It's a very original way of solving it. And actually, we know that there has been translation of the approach to the end user via the sponsors we had for the project. So very satisfying to take a hard, important, real-world problem and get somewhere with it by replicating its dynamics with our coevolutionary algorithms. So that was a very good success. But what next? We sat around and we've been working on taxation for 6 years. We knew an awful lot about tax. What were we doing? Like, we were almost lost in the weeds. But nobody else was. They were hearing us give high-level conversations about high-level talks about this. And all sorts of people came up with regulatory examples that are similar to taxation, where they saw coevolutionary behavior. I was seeing coevolutionary behavior everywhere. I was putting birdseed in my bird feeder, and I was worried about the squirrel fighting me in a coevolutionary arms race, right? Getting to the bird feeder to feed before the birds. And we finally connected with people who are very interested in cybersecurity. And they said, that's the key, important, real coevolutionary arms race you want to study, UNMA. Right? So that's what we did and have been doing for 6, 7, 8 years. We have a system called Rivals. And now the competition environment moves from the Internal Revenue Code to cyber networks. And we're worried about the predators being threat actors who might DDoS your system, or who might actually, get in your system and be performing reconnaissance to figure out where all your assets are. And we know that the only means in which we can defend against those is we might be able to self-repair a system that has been invaded by DDoS, or we might be able to, deceptively capture and slow down the cyber threat actor who's in our system doing that reconnaissance. So this, again, was a large team of students, led also with me by Eric Hemberg. And let's just put the prototypes in. We have predators, attackers, threat actors, and they are competing with cyber defenders. And in the real world, there really is coevolution. I have lots of examples of it, but I picked this one for you. This is a slide published by a very large global content service provider in the US, and they were getting DDoSed when the time DDoS was really big. And what they were tracking was the evolution of more and more sophisticated DDoS attacks. That's on the upper side of that chart, and on the lower side, or the lower side of the plot line, what you see was what they were doing about it. And they were like, well, we did this, and then they did this, and did this, and then they did this. So they were very interested in our work, this particular group. They were one of our supporters. But I don't really want to tell you again how we represented attackers and defenders and how we had a fitness function set up at competitions. What I want to talk about now is how we extended coevolutionary algorithms to have another piece to a larger framework. And that's to be able to answer a couple questions. One is, if you're actually using coevolutionary algorithms, you want to find the solution you should use, right? And you want to know, if you're the engineer who did that, you want to know, well, what algorithm got me that, and what solution concept got me that. And that wasn't available at the time. So what we started to do was, we had several versions of our algorithm. They used different solution concepts, and every time we run them, we would save the best of generation and the best of run into this big cache, right? And what that gave us access to is post hoc, after all the evolutionary runs, we did what you would think is very obvious. We would select, on the basis of solution concept or on the basis of algorithms, we would select some of these individuals from different runs. They'd be involved different ways, and we'd have a champions tournament. We'd run them against each other, and based on some solution concept, we could rank them. And this allowed us to point to different solutions and say why they were good and how we got them. It's a very complicated slide, but if you just look at one of those quartiles, say the top right, my right, what you can see is where we ran 3 of these champions tournaments. We used one particular, all the tournaments used the same solution concept, but what we were doing was taking different attackers and defenders out of our population. And what that allowed us to see is that certain certain algorithms were actually giving us better solutions than others. And we could now pinpoint those solutions as the one we went and looked at, and we could see exactly what they were doing when they were doing network defenses in some way, or network attacks. And that's all I wanted to say about Rivals, except to say that by the time we finished with Rivals, after 8 years, and having done the stealth project, we were getting good at it. It was really messy the first time we used coevolution for taxation. We were so busy learning all these different things. What didn't pop out was the regularity and what you reuse and modularize and sort of keep as a system. And that's what popped out of Rivals. And so what you can kind of see is that we were like, okay, any example people give us, we can identify attackers and defenders, we can come up with their grammars, and we can define some engagement environment and come up with the fitness function. And so, the use case would come in, and we could reuse our algorithms with a little bit of ingenuity. So, that's the Rivals project. And again, while we're doing that, we don't have enough to do. We're keeping our eye on machine learning, right? Other kinds of machine learning besides evolutionary computation. As you know, statistical machine learning, deep learning, it's all becoming quite, it's showing significant gains. And we came across a kind of machine learning, generative adversarial networks, or GANs. And we were like, oh my God, we don't have to go and learn about taxation. We don't have to go and learn about cybersecurity. We have in our own backyard a computer science example of an adversarial relationship where there's even a arms race between 2 neural networks. And let me explain that. But we investigated these adversarial systems, computational adversarial systems, with a system called Lipinzaner. And I want to call out Jamal Tutu, who's here, and Eric Hemberg again, who's here, with others who have really helped pioneer and bring the Lipinzaner system around. So let me start by telling you what a GAN is, generative adversarial network. Say I give you a bunch of pictures of horses, and I say, I want you to come up with a neural network generator that's going to give me horses like them. Because there's some distribution that defines horses, and I've only given you samples, but I want you to learn that distribution. That's called a generative model, and we're going to learn that generative model as a neural network which we find the parameters for. Right? In order to do so, we're going to set up an adversarial paradigm. We want that generator to generate images, and at first before it's trained, they may be terrible, but as it gets more and more trained, they should look more and more like horses and reflect the distribution that's underlying the samples. And we're going to have that generator pass its samples to a discriminator, which is another neural network. And that neural network will also receive the real samples. And its job as a discriminator is to say fake or real. And the important part is that when it takes a fake sample and is fooled, that's going to be positive feedback to the generator. So we can adjust all the weights with the gradient descent. But when it finds the fake sample, it's going to be negative feedback to the generator, and we can train the generator better. Okay, so that's like a min-max problem. It's an adversarial example. I'm interested in that. Well, what was going on in the field? Well, these GANs turned out to be really hard. You know, we were pushing one side to extinction or the other, or we were oscillating between modes of the optimization criteria, but not getting all of them. This is what was happening in the machine learning community. And we sat back there and said, oh, is there an opportunity here for evolutionary computation? And that's because evolutionary computation uses populations. So we can create a population of generators and a population of discriminators. We can judge their fitness by taking one generator against many discriminators and one discriminator against many generators, right? And maybe some of those will have these pathologies, but they won't survive. So it's not that our evolutionary algorithm didn't encounter these pathologies, it's just that it moved past them. And you can't move past them when you just have a 1v1, right? So if I draw a picture of this, there's our 1v1 generator discriminator. What we tried first was we just had populations and we ran an coevolutionary computation algorithm, right? Coevolutionary algorithm. Sorry. Well, that's the one thing that's up for option there is how do you actually train the neural networks? You could train them with evolutionary training, that's just super slow, or you could use the gradient, right? So we'd use the gradient, but we still were stuck with this fact that it was going to be an n-squared complexity. So instead of that, we took these two populations and we mapped each of them to be on a single two-dimensional grid of cells. And at each cell, we put one generator and one discriminator. And for that cell, we defined a neighborhood, which was all the generators and discriminators to its north, south, east, and west. And because you can do that for every cell, then these neighborhoods overlap. And that means that when you change one generator and discriminator in a cell, it's going to have impact on its neighbors, right? And when we do that, we get an order n computation, right? And we can distribute it very fast. And we can basically now hybridize, gradient descent learning with evolutionary learning, because now we're going to run a little coevolutionary algorithm in our neighborhood of 5 across this whole grid at every cell. So what do you get? It's amazing. The pathologies are resilient. We're resilient to the pathologies. That doesn't mean they don't occur, but they just don't stay. It turns out to converge faster and better on the benchmarks, and it scales well. And we get good, robust solutions because in the end, we put the solution together by combining neighborhoods. So we get an ensemble solution. And since then, we've gone on to really enhance Lipinzana with all sorts of ways, lots of GECCO publications. And in fact, this year, we even tried cooperative instead of competitive coevolution because we put an autoencoder in the cell. And that would be an encoder and a decoder cooperating to come up with a latent representation that was accurate for some set of data. So that's the 3 case studies. Now, I'm putting up this book, which is another really foundational book in genetic algorithms. It's by David Goldberg. It was the second book of my PhD comprehensive exam. And it's actually more reflective of what I just went through with you, because it was the first book that actually put out code for genetic algorithm. I typed the code in after reading it in the back of this book, right? And it showed how you were going to do exactly what I was talking about, choose representations, choose fitness functions as well. So that's a book that's more indicative of what I just told you. But remember, I talked about being inspired by this book as well. And this book is a much broader scoped book. It's about the relationship between how natural processes emergently give rise to intelligence and artificial intelligence. And that's really what I was able to do after these iterations of these case studies. Somewhere along the way, I realized I wasn't just an evolutionary computation researcher who was replicating natural systems with my artificial ones, what I was doing was replicating adversarial behavior and adversarial intelligence by coevolution. So truly, I stand before you, and what I work on is artificial adversarial intelligence. And I've shown you how I'm trying to achieve artificial adversarial intelligence with coevolution. But of course, there's other ways to do it. So just before I stop and take questions, I wanted to show you we're completely outside this community. Just to sort of remember that we should keep our heads up and remember that there's lots of other things going on. And so I'm still trying to solve those cybersecurity problems. And I can certainly do some replication with my coevolutionary algorithm. But of late, I've really tried to think about the adversarial intelligence one agent might have when they have to actually conduct a cyber campaign. So an advanced persistent threat where once they're in a network, they need to perform reconnaissance, figure out what vulnerability in the network to exploit, and then actually run that exploit to exfiltrate something like data that they shouldn't have, right? And that level of intelligence for an adversary in cyber, for that I resorted to using, I thought a lot about planning and reinforcement learning, and what we're doing right now is we're using large language models. So I thought I'd show you this rather intriguing large language model supported pair of cyber agents. And we built an environment which is a very close to realistic containerized cyber network. And we have a cyber agent that's doing penetration testing on that network, which means that it's acting as a malicious actor. And we give it access to the keyboard. And the LLM actually helps us find the commands we can issue at the keyboard to do reconnaissance on that machine. It helps us understand the results that come back to find the vulnerabilities. It helps us choose the exploits we can use to run against those vulnerabilities to run the exfiltration. So it's truly astounding how much we've been able to use it. And what we'll work on is improving that and extending that to other sorts of adversarial threats. And of course, we're also thinking about the blue side, which is how we make adversarial agents with LLMs. And one day, I want to wrap all these guys in coevolution, right? And then I'm going to get closer to this reality of replicating, learning, co-evolving cyber actors. So with that, I'm going to leave you. I'd like to say thank you for your attention, and thank you to the organizers in Melbourne and that koala. And I'll take questions while I run my thank you reel.
Thank you, Yunumei, for that very inspiring talk on coevolution, mostly remembering there's more to our field than just plain evolution. So, are there any questions from the audience?
Thank you. That was wonderful. I thought I would first share something you might not know. Some of us had been in the field a long time, knew and know Dave Davis, right? He actually wrote the code that decided who to audit at the IRS. I don't know if you knew that.
No.
And so somebody from our community actually wrote that code. And I agree with you that I think our community could benefit from paying more attention to real-world applications, because it just brings enormous complexity to what we do. And if we aren't considering that complexity, then I think we're missing out. But I'll let you riff on that if you like.
Well, I was reflecting a lot on this, and life is a lot. Your academic career is a balance between exploitation and exploration. And some of us tend to have careers that are on the exploitation side, and those might be considered even safer careers because you know something and you're just finding out more about it. You are legitimately and really respectfully finding more about it. And on the other side of the spectrum, there's people who are very risk takers and they explore. And guess which side I'm on? And you want to be lucky enough to have the resources I have and the community that tolerates that risk taking. And then you can kind of make these explorative steps rather than the exploitive steps. And I'm totally envious of all of you doing exploitation. but I'm an explorer. Jürgen.
Yeah, thank you very much, Una May, for this great talk. And as Daryl, I really admire you for being brave enough to go out and tackle these really risky and highly complex problems. And I really like the tax evasion problem. But I was wondering, rather than co-evolving attackers and auditors, can we not co-evolve the tax system and make it safer so that I think that has a longer lasting effect, right? The auditors have limited resources and they need to move back and forth and back and forth. But if we change the tax system using your coevolution, maybe then we have a longer effect.
No, I think that's a wonderful insight. And I think if you took me back to 2015, 14, more than 10 years, I just didn't know how to do that. I couldn't imagine how I was going to evolve tax code. But give me an LLM, and I'd think about it now, right? Because the tax code is in language, and we can actually talk about modifications and patterns in language terms of the tax code. And so you could imagine, I was actually thinking that it may even be an open-ended system where you have the co-evolution of the tax code, the evaders, and the auditors. But yeah, I don't think, actually, when we started, we knew how to build an evader. We didn't have a clue how we were ever going to figure out the other part of the arms race. Like, it took us a long while to scratch our heads and come up with auditors and observables, because we were sort of stuck on that. We were like, well, they keep on telling us they're just changing the tax code. And then we realized they weren't always changing the tax code. They were just changing the tax not the tax auditing. So I think it's a great idea, and I think the time is ripe for it, for someone daring. And someone willing to put in that amount of information to learn about the tax code.
Hi, Una May. Thanks.
Dennis was my Europe.
Yeah.
He was an undergraduate in my lab many years ago.
13. This was a great talk, and it's wonderful to see all the things that Alpha has been doing over the past couple of years when I've not been there. I was wondering, I saw your joy and I share in it when you get to working on GANs, because finally it's a application domain that you know, and that's much easier than tax evasion and cyber. So I was wondering if you could share some of the lessons learned about those applications and the learning process necessary to work on them, and maybe some pitfalls to avoid, because we need to do that sort of applicative work, but it's not easy, and especially for evolutionary computation.
Yeah, so to work on real-world problems takes a real commitment. And so it has to come from really talented students who are willing to make that commitment. And the commitment you're asking about them is not just to be narrowly interested in evolutionary algorithms, where they can use benchmarks per se. They have to actually invest their time in understanding another domain. Right? And that's actually the big ask of them. So one of the pitfalls is getting a student who just wants to work on the algorithm but not on the problem. And the other pitfall is that you have to go and devote the time to learn about that. And that's all about relation building. It's not like we learned the tax code. We learned people who could teach us the tax code in the way that we needed, and people who could check what our understanding were. So you have to build these relationships with people, and that's actually very gratifying. Some students, and me, I like that. I like learning about new things. But one of the pitfalls is sort of saying, well, I'm going to choose one very simplified perspective on the real world, and then I'm just going to stick there and with blinders just pay attention to that, because you run the risk of it being irrelevant to the real world. So you want to simplify and abstract, but you don't want anything simplistic. And there's an art form to that. And I mean, our benchmarks reflect good simplification, and any ones that were too simplistic, we've gotten rid of, right? So as a community anyways. So I would describe that as sort of my sort of philosophy towards it. Pitfalls, well, there's lots, right? You can get it wrong. And you can get stuck. Like did we avoid trying to figure out how to come up with auditors because we didn't know how. But eventually, we scratched our heads enough and got it. Someone else.
Yeah. Thank you for the great talk.
Hi.
I was really interested by the tax evasion use case. And actually at ICML last year, I think, there was a a keynote where people were using machine learning to predict which students were likely to drop out of school before the end of high school. They got really good results, and the conclusion was unfortunately quite depressing because it was basically politicians don't care. So basically, they build a really good algorithm, but they fail to have it actually impact the real world. And in your case, it seems like you actually managed to have a concrete effect. And I'd like to pick your brain on how do you think scientists like us should try to interact with politics and, let's say, public institutions to make sure that our work actually is useful.
Yeah, well, one thing is to allow them to give you money because they'll take it away if you're not doing the right thing. They kind of hold your feet to the fire. I mean, I think that's it. Yeah, we have absolutely had good relationships with the Revenue Service or the representatives and indirect representatives of it. We've also had that with cybersecurity. We've had access to people who know what's important and told us what's important and who are waiting for the results, per se. So I think in some sense, again, it's about the relationships I spoke of before. You know, a relationship isn't short-term just to learn something and leave and do it and present it as a paper. It's sort of saying, well, how do we invest in taking this solution forward and translating it? So it's an investment in time and for relationships, I think. And I'm looking at Ryan, and he does medicine. Like, just be in the medical field. You have to invest a career in getting your stuff to translate into the healthcare field, for example, right? And so it's done. There's people around this room who have done a very good job of it beyond me.
Hi, really great talk. So I am going to ask this question in the context of the tax code example, but I think it kind of applies to all of them. So that's a really cool model of the behavior that's happening between the auditors and the tax evaders. But obviously, like in that system, they're locked in this coevolutionary loop where the auditors aren't always winning like you might want them to. Have you thought about adding kind of another level like on top of it where you're trying to come up with a strategy for auditing that will, instead of being locked in the loop, have the auditors win?
Yeah, drive it right out of existence, right? We really do want that pathology that the GAN people don't want, right? We really want to have not mode collapse, but what's the other one called? But the collapse of one population. And it has to be the good side, not the bad side, right? And like, it's interesting because I really want that in cybersecurity. And the problem is it doesn't happen in cybersecurity. Like people, get an attack and they fix it and the attackers come back somewhere else on the attack surface. Like it's actually called an attack surface and you're trying to guard it. It's just like these observables in taxation. And it happens again and again. So how do I drive that population into extinction? Well, in the end, honestly, one of the things is you say, well, I'm going to do this job so well, that attacker is going to go attack someone else, right? And I'm like, when you look at it, coevolution takes place geographically in a spatial way. So these attacks come out of various states in the east, the axis of evil, of 4, whatever people call them. And so Russia tries its attacks out first on the Ukraine, and then they travel across Europe, and then they hit North America, and we all start patching and finding all the vulnerabilities as they do a little bit of modest incremental evolution. And then when we've all locked it down, it goes down to South America. And it goes to Africa. So one way, unfortunately, is just to run faster than your friend when the bear is chasing you, right? But the other way, I think, certainly when I think about cyber and I think about law, you have to do what Jürgen's suggesting. You have to fundamentally change the tax code. People in Sweden have the tax code and file their tax on their phones. Americans pay people and submit huge papers, huge numbers of pages of income tax. So we need to simplify the tax code. And we actually need to build systems, cyber systems, that are secure by design, not with security strapped onto the end. And unfortunately, until we can sort of take away these extant systems that have not paid attention to security earlier, then we're going to get stuck in these loops until the new systems replace them where security has been really from the bottom up when they were designed. But if you have any ideas for how to simulate and get them there, I can think of them and just take away the resources or something, but I'd love to talk more.
Thanks for
online. Great.
What is your future version of Coevolution?
What is my future version of coevolution? I am going to have a co-evolving framework, and my agents are going to have genotypic and phenotypic definitions that allow them to cognitively reason about attacks and then actually turn the plans that they cognitively reason about into actions that they execute in a very high fidelity environment. Oh, you asked. So glad. But that's it. I really want smarter agents. I want to take this notion of adversarial intelligence and adversarial learning right to the agents and then put them in the co-evolving system. So I really see the dynamics on a much more complex level.
Hi, thank you so much. I'm particularly interested in GANs, and I'm very new to them. But so you kind of showed the example where it was learning to generate images, right? But I'm sort of interested in ways that GANs and your evolution of GANs could help with our field. So for example, maybe this has already been done. Sorry if it has. But for example, an instance generator. So you feed in, okay, like TSB cities on a plane, and it learns how to generate instances, or the same with algorithms. I mean, maybe this has been done, but what are your thoughts on that? Whether
Well, I think generative AI, where we take samples and we learn a distribution which allows us to probabilistically describe it, or in some ways describe it, so that we can generate new examples from that model of the distribution. I think that's very powerful. And like GANs in some sense are passé, because what's supplanted them is large language models. So large language models are underneath them. They're transformers. Transformers have multiple layers of attention heads that take the inputs in sequence and group them all together with a feed-forward network. And these can be trained on tons of data. They can be, they can have billions of parameters, and they can be trained in parallel. And they're generative systems. That's all they are. You can work with a language model and you can think it's understanding you, but it's not. What it's doing is it's taking your input and it's finding out what the pattern is most likely to finish your input, and it's giving you that as output. That's all it's doing. It has this superficial appearance of understanding what you say, but what it's done is it has been trained on a fantastic set of patterns. And that's why we can't ignore generative models, because the patterns embedded in them through the training reflect human behavior, and in some ways, I think they reflect the physics of the world, right? Because human behavior is co-evolved with the physics of the world. And so what you've captured in those models is something about the world and about how we behave in it. It's not an answer to everything, but there's something very deep and rich in these models. And you can do the things you're talking about. You have to be careful because they're going to hallucinate. There's many, many pitfalls with using them. But this opportunity to access this repository of human behavior through captured through patterns, I think is really interesting. And the way I've also described it once is that, right now we work with computational paradigms. We think a lot about programming models, and we teach students that, there's operators and operands, and these operators can be mathematical or whatever, and the operands are data that, we pair with operators, and we work with this programming model. Imagine we changed the way we think and we worked with pattern models. And we just thought about the whole world as something that we had to solve by pattern matching and pattern extension. I'm not saying it would do anything, but it's a different computational paradigm, and putting those two things together, I think would be extremely interesting. Yeah.
We're nearing the end of the session, and I wanted to put one question before we move to the closing session.
And there's someone online too. So two?
So,
quick.
okay, well,
two.
You're the boss. So, okay, one online question.
Have you come across an engineering popularity problem in the case of social networks using adversarial bots to form likes or opinions?
I didn't quite hear it. I'm sorry. Have I come across
an engineering popularity problem in the case of social networks using adversarial bots to form likes or opinions?
Yeah, so I think, when I think of adversarial behavior, and I want to always look at adversarial behavior that has large consequences. And so obviously taxation is about fairness. Cybersecurity is about protecting our systems. I think also about information, right? So disinformation campaigns are adversarial in nature, right? There's threat actors, there's malicious actors out there seeding campaigns with social media, and how do we defend against them? And so I definitely think a lot about the social misinformation and information defense behavior as from an adversarial perspective. Yeah.
It's not a competitive game because all of them just maximize their profits.
I think it is a competitive game because I think there's people trying to shut it down. I think that at some level in social media we have to decide that there is a truth, and some things are not factually correct. And so whether or not the objective is to make money or the objective is to change someone's beliefs, then that's an adversarial action upon a group of people who want to understand the truth. So that's how I would look at it, yeah.
All right, so before we get to the closing session, I have one more question. Maybe a meta question. So you have, of course, these amazing applications, and the last one you're moving towards neural network stuff. There's GANs in there, there's large language models in there. And in our field, of course, we're proud of what we're doing, but there's this other field, the deep learning people. You're some beautiful examples of things integrating. On the other hand, is that not a co-evolutionary system as well, right? They're moving ahead, we're moving ahead, and they're sort of doing stuff that we were doing, and just as a inspiration for our field, how do you see the future? Is it co-evolutionary, and if so, how do we interact? What should we do? Where should we go? Any advice from you to us?
Well, I think it's dangerous ever to be committed to one thing. So when I think about the co-evolution of two populations, the statistical machine learning community that's really data-oriented and the evolutionary computation community, I think we want cooperative co-evolution, right? I think it pays to have our papers being presented in their communities. It's really helpful when we invite people from their communities to explain what they're doing to us. And then these hybrids emerge. And I think we're going to learn the best. And so I think you can still improve when you cooperate. And in fact, it may be more fun to cooperate than compete. It's just as effective. So I would like to see it as a cooperative, co-evolutionary relationship.
All right, thank you very much. And with that, I would like to thank May one more time for this excellent keynote.
Thank you.
All right, there's a 10-minute break in the program, but instead of that, I would like to propose, because everyone wants to get out of here and enjoy the great Melbourne weather. So I would like to actually ask everyone to stay seated. We move on to the closing session. I would like to invite the general chair of this GECCO, Xiaodong, up to the stage.
All right, so we're coming to the end of our conference. In the last few days, I just hope you have learned a lot from this conference, just like myself. I think there's a lot of idea that we can learn from this experience. GECCO is a flagship, the top flagship conference in this area, and we really, I hope just you take away the idea we have learned in the last few days, and feeling inspired, and go away perhaps to have even more successful research career. So we have a lot of things to go through this closing session. First thing, of course, I would like to thank a lot of people that putting together this conference, makes this conference such a successful. And we have other things to cover, the summary of the GECCO 2024, some of the statistics, and summary from our SIGEVO committee. As you can see, we're going to give out award of best paper and competitions. Then in the end, we'll have the 2025 announcement, promoting the next GECCO. So first of all, I would like to thank the SIGEVO committee, the business committee, and Honor and Manu for their support, and our SIGEVO officers. As you can see, Peter, Emma, and Marcus, and Francis and Jürgen for their continuous support in the last year. Yeah, whatever we ask them, they've always been really supportive to us. And our sponsors, first of all, the Melbourne Convention Center. So they, Convention Bureau, they provide the local government sponsorship, secured the venue, and our university like RMIT and Optima, they're the gold sponsor, providing a lot of local support. Of course, we have other sponsorship, as you can see, from other institutes. First and foremost, I think, yeah, we would like to thank you guys, the attendee to this conference. You're the one that makes this conference such a prestigious conference, and you know, we have learned so much from coming together to this conference. So I really want to have a big thank you to all of you guys, yeah, for making it. As you can see, we have 666, a lucky number, registration, and I believe the online attendance is probably one of the highest, much higher than last year. 43% people attending online. Perhaps have something to do with the Australian being far away. So this hybrid mode conference really, I think, play a very important role to bring together the community. Yes. So we have some fantastic keynote speakers. I learned a lot from the keynote like today. You know, we have such a rich idea in this community, bringing not just evolutionary, nature-inspired idea, but also machine learning. You can see yesterday we have keynote from other areas. You can identify some of these common theme, right? We all can learn from each other, no matter what kind of research you do. So of course we have 32 tutorial speakers. They have fantastic, various topic area of tutorials, papers and posters, and other speakers. So would like to thank all of them. For our local organizing team, as you can see, hybridization, scheduling, these are some of the very challenging tasks. So I really want to thank especially this hybridization and scheduling team, Yuan Sun and Mario, Sue, DJ, so for really putting together this schedule. And we have so many hours spent on just to try to resolve conflict. As you know, we have this hybrid conference, a lot of people from overseas, and there's a different time zone you have to deal with. So big thanks to our hybridization team. Yeah. And other people like electronic media covering, the website of it. Also, Harad, Masila, and publicity like Richard and Kate, and student shop, student affair, Ian and Grant. Sponsorship, Frank and Andy, and so on. For event organizer, so we have poster chair, Ming-Ju also, because it's the first time we use Hoover as a platform for hosting the online poster. So there are some also learning experience for that. So that we spent a lot of time just to try to make some of these adjustments necessary to make it really sort of smooth running. And we had a student workshop and tutorial chair, Meng-Ji and Emma, really big thanks to them for they put together all these fantastic tutorial talks. And Heyman for competitions. We have 12 different competitions. There are 32 awards given out. So that's really a fantastic program there. Women and the GECCO is a big success. On that night, I think we have more than 45 people showing up. Very stimulating discussion there. So thanks to Bing and Data. For late-breaking paper and hot off the press, Marcus, Will, and Jacinta. Hume competition, Eric. Yesterday, I noticed there's a huge attendance for the Hume, drawing a lot of attention there. So that's really great to see that a fantastic scheme continue around for many years. Yeah. And we have also the summer school, first time co-hosted together with Optima, another conference run just before the GECCO. So that was really successful, attracting some students. They have learned from their mentors. Very successful. And job market by Tia and Boris. Oh, one other thing, of course, for two people I really want to thank most is Julie Handel, our editor-chief, and Marcus Wagner, a local chair. So can you just put your hands together? Big applause for their here. Yeah. And I want to thank... And Julia, you've been such a wonderful, team player. You're very thoughtful. Your attention to detail, your dedication, second to none. Every time I meet something, you pick it up, and then I learn from that. So it's such a wonderful team. Sort of, I think we have together with also Marcus. So Marcus bring on a lot of experience from running GECCO in the past. So because for me the first time, but he already run that before. And also, I guess, the advantage for him being a SIGEVO treasurer. So I have a lot of this inside information learned from Marcus. That makes it a lot easier. So we have a really nice team. I think even the time zone works in our favor, because every time we have online meeting, I know I have a meeting every Wednesday night, and then the second morning, Julia already solved all the problem, because I just wake up and solutions already there. So that we can really, I think it's fantastic. We have this team that work even in different time zone, and we can make it really efficient. Yeah. So I think next I would like to ask Marcus there. Yeah. To give thank you for our local student volunteer.
Thank you. Well, Xiaodong, you'll be taking the stage in a few minutes again, anyhow. But also it has indeed been quite an event, quite a journey. I will very much like Xiaodong also read out the names of the volunteers, at least the given names. As Dale Carnegie famously said, a person's name to them is the sweetest and most important sound, joking in any language. Makes them feel valued, and we have a lot of value here in this community. It's an event organized by the community, for the community. We'd like to thank many people, and I will probably, as I apologize if your name does not appear on this slide or the next one. We have locally many people helping, and it really makes a massive difference if you have people local, simply here in Melbourne or in any city. If you need somebody with a car or several people who pick up things at, 6 o'clock this Sunday morning, bring things from RMIT University over, it really helps when you have people that you can rely on. And we've had many, many people that we could rely on. So among others, we had Hongjie, Andrew, Parham, Alex, Aidan, Vic, Kendall, Yameng, Iliao, Rimin, and Yunchang helping us here locally, and many, many others as well. Can I please? Yeah, so. They all put in they all made quite an effort to make this event happen for everybody here. Now, we do have many, many other volunteers who have helped here over the last couple of days. And may I just for a moment ask those who are listed here to stand up as well. So among these, who do we have here listed? We have Bag, Andrew I saw somewhere. Just please stand up for a moment. I want you to be seen by the others for several reasons, and I'll tell you in a moment. So Bohan, Gitanji, Ivi, Farshid, Georgia, Ian, Josh, Malise, Karim, Kwan, Sayed, Kaya, Yangji, Aidan, Berus, Brandon, Emily, Faisal, Gayatri, and we have a few more. Hey, well, everybody, please keep standing. No, there is a reason. Please keep standing for a moment. Please do me the favor, just 1 minute, all right? And then here's Bizard, Cedric, Everardo, Khalid, Georgia, Goldie, Johnson, Kendall, Minmai, Julian, Wilmin, Sri, Young, Sijon. The reason I want you to stand is all the academics, have a look at these clever and passionate people. They will, well, some of them are on the job market, so if you're looking for someone whom you want to grab, get in there early, because otherwise somebody else will. And these, as you can see, they are the ones who do something for the community. So get in touch with these clever people and give them a job or mentor them at least. Thank you. We also have a number of professionals who help us, amongst other Roxanne, Stephanie, and Brenda. Roxanne is somewhere in the audience. Where's Roxanne? Can't see her at the moment. She at the back. I can't spot her. Oh, there at the back. Yeah, it's the very end. So can we please put our hands together? The reason we need to thank them, even though we are paying them, is they pay attention to so many little aspects and big aspects. If they weren't there in place, many things would not be running this smoothly. In case you have not seen anything on fire, it's largely because Roxanne had an eye on things, and we have simply been mending things along the way. I think you've been looking after geckos for way over 10 years? 2011, so you're 13, 14 years. That's fantastic. There's a lot of information passed on, experience passed on from one gecko to the next one, even though two geckos are never really the same, especially, well, since the pandemic hit, and we had to go online, then now we are hybrid. It's amazing because we all are volunteers on our side. Things get lost over time, and we also have to adapt, as we can see. And also, we don't get to see really that much what works and what doesn't work at other conferences. So having professionals like Roxanne and her team, they're in the back, well, not necessarily background, often also foreground, who also contribute to other events, large events like Kai, is immensely helpful for us. So thank you. Good to have you on the team. Speaking of, well, simply running things, we couldn't do this here without the Melbourne Convention and Exhibition Center. I'm sorry, I don't have too many names, but we do have, so we did work a lot over the last few weeks and months with Danielle, Shane, Erin, and Part. We also have our team of roaming and not so roaming, more stationary technicians here. So the only names that I could think of or remember are Abby and James. We've got, how many sitting there at the background helping us? At least three gentlemen there, maybe four. It is, yes, many of you will have seen we had a couple of birthing issues or also some issues at the very beginning. But it's only because the venue supported us and they have been immensely accommodating that in the end, I think the hybrid experience was overall quite all right. It's only because everything is in place, software, hardware, maybe sometimes 5 or 6 solutions in parallel, and we had to converge to a particular solution in the end, but we had enough backup plans in hand, and it, from what I can tell and from what I've heard, many of you have been quite satisfied with the venue itself, with the AV experience. So a massive shout out here to the AV team, to the team of the catering as well, who worked tirelessly to provide us with lots of coffee and hot chocolates. I've heard that hot chocolate has been incredibly popular here. Thinking of catering, some of you may have seen that some of the food has unfortunately not been eaten. You may be delighted to hear that the Melbourne Convention and Exhibition Centre works with OzHarvest, who donate food. OzHarvest is a big company here, or organization here in Australia, and for the last 20 years they donated something like 250 million meals to the needy. So it's fantastic to hear that from a sustainability point of view, well, some food probably gets wasted, but not all of it. So there are at least efforts somewhere in the background happening or going on to make GECCO as sustainable as possible. Security has also been incredibly helpful. One evening they escorted us out because we had to use one of the facilities a little longer than initially expected. We also had some members of the public who had to be escorted away at some point. So all these things that you all probably have not noticed, but where the venue itself has been incredibly enabling and accommodating. Cleaning also, a brief shout out to them. I think everything is pretty much spotless here. It's not for granted if nobody really looks after us and you have a bunch of academics just getting together. I think everything outside looks fantastic. That's it from the. That's all that I want to say about the convention center. I think it is a paid place, but from what I can tell, it's pretty good bang for the buck. So thank you, Melbourne Convention and Exhibition Center. Now I will stay here for another 2 minutes. Speaking very, very briefly to sustainability. Jürgen, where's Jürgen? Do I see Jürgen somewhere? Jürgen, I think, did we say that I talk or you wanted to?
I'm not prepared.
All right, good, then I'll talk, sorry. Yeah, wasn't it? Right, let's start with one point. I know, these badges here, I know some of you like to collect them. If you want to do something for the environment, maybe at least hand back the plastic sleeves. There's a big cardboard box at the welcome desk. If you just drop your plastic sleeves in there and they'll get reused. If you want to, in principle, you can hand back the lanyards as well. If you hand them back, we would wash them and then find some use in the future again, but also, of course, you're most welcome to take them home. On the point of sustainability, we pride ourselves to be nature-inspired. Hopefully we do leave the planet behind for our kids in a somewhat livable state. Towards this, some of us would say we have to look after our CO2 footprint, and to support our analyses in that direction, Carla Silva from the University of Lisbon, she's been doing some analyses since last year of geckos. What's an estimated CO2 footprint of a gecko? I'll have a couple of numbers for you on the next slide. I'll talk you through them. So she's done the analysis for last year. She and her team has done the analysis for this year. The numbers themselves are maybe a bit abstract. So what is a ton of CO2? I have trouble thinking of this besides being some big black block somewhere. Maybe to make this a little bit relatable, apparently across the world, the average person produces about 4 tons of CO2 across the world. So this includes developing countries as well as more developed countries. Apparently in the US, the average is about 16 tons. I couldn't find out the average here for Australia. For this very gecko, average production, so keep this number of 4 in mind across the world, and the average CO2 footprint here of every attendee is 2 tons. It's not quite a super fantastic number given that we are having a 4-ton average per person. Those who have participated online had an almost negligible footprint. So from a sustainability point of view, probably everybody would have to go online, or we should be going online. It's a little bit a tricky thing for us to decide, right? We love to mingle in person. It's just not the same if we are in a Zoom breakout room. I wonder what we can do differently in the future. Most of the CO2 here incurred is because of our long-distance flights to come to this place. Last year for Lisbon, most of the attendees did have to fly in as well, but they flew in between, or they had to fly for about 1,000 to 2,000 or 3,000 kilometers. Here, for Melbourne, it was more in the order of 15 to 17,000 kilometers. That were the vast majority of people. So it's great to have everybody here in Melbourne. But for the CO2 footprint, that was probably not the best thing after all, unfortunately. Having said this, the hybrid setting nevertheless helped us to reduce the footprint to about, so on average, you might remember Xiaodong's numbers as well, so we do average out to about 1,300 kilograms, 1,400 kilograms per person. This is still roughly twice as much as in Lisbon, simply because of the flights. So we have to find some other way. Maybe satellite events are a way forward in the future, or several smaller events. I don't know. Talk to us if you want to pitch some interesting ideas here on what we can do differently in the future. Very briefly, 2 or 3 points, and then I'll let Julia take the stage. Locally, we did try to provide you with food that is locally sourced, with wine, beer that is locally sourced. You've got conference goodies that are reusable. Here in the venue, also the water was typically, or the coffee was served in metal cups, reusable cups that are reused. Some of you might have attended the conference last semester. I have to stab at it a little bit, and there were tons and tons of water bottles accumulated in the breaks. We didn't have this, luckily, here. So lots of reusable cups that were washed and then reused. So much better there for the environment. We will, for future GECCOs, probably look into carbon offsetting. Sometimes conferences can do this on the legal side. We had at some point looked into it, and it's not trivial to bake this into the registration fee. But we'll see what's possible there, maybe with the landscape simply changing. That's it from my side, from the sustainability point of view. If you want to talk more with us about sustainability and how to run conferences more sustainably in the future, talk to Jürgen, who is the SIGEVO Sustainability Chair. Yeah, that's all from our side. Thank you. And I'll hand it over to Julia.
So I wanted to briefly continue with thank yous and move to all of the track chairs that have helped us run the now 15 tracks of GECCO. What you can see highlighted in blue are the 2 new tracks that we run this year, benchmarking and the Learning for Evolutionary Computation track. And the reason why I wanted to highlight those is that the track chairs on those tracks did a particularly large amount of work to actually shape those tracks, to come up with the track descriptions, and select new reviewers that we had to find somewhere. The other track actually that I wanted to mention in that context is the GECCO track, General Evolutionary Computation Hybrids, because again, I had 2 new track chairs there, and they had to liaise a lot with our 2 new tracks in order to agree on where reviewers would go and how they would differentiate their scope from each other. We've had a fantastic team there, 30 people helping ensure the scientific quality of the conference. They've all done a wonderful job, and I'm really grateful for all of their help. In terms of submissions, so this is submissions and acceptance rates broken up by track. One of the things you can see here is that actually both of those 2 new tracks that we've run this year have been incredibly successful, considering that it was the first year of running them. Yeah, so they immediately started up as medium-sized tracks rather than the smallest tracks of the conference. The other key takeaway, I think, from this slide is that we do have some tracks with very thorough but very critical reviewers. So if you're reviewing for that track, maybe you want to think about being a little bit more generous next year. So we have some fluctuation in terms of the acceptance rates that we're aiming at. And yeah, so some of our tracks, well, very, very thorough reviews, but people maybe being slightly on the harsh side in assessing the overall quality of papers. This is the acceptance rate this year in a historical context. So you can see how this year's acceptance rate and the number of overall submissions and full papers compares to a long history of GECCO across the world. And we're incredibly proud that we were able to attract that many paper submissions despite the location of the conference in Australia. As Marcus has just highlighted, it's been a long journey for many people to come here. We got a lot of attendance. A lot of people chose to attend online, which is great. So a very, very successful hybrid GECCO, which is what we set out to try and deliver. This actually, just to sort of dig a bit further into that point, so these are our top 15 countries in terms of in terms of the country of work of the first author of accepted peer-reviewed submissions so peer-reviewed submissions either in the main tracks or in the workshops. And you can see Australia there in second place, which is obviously very nice to see, and kind of reward some of those efforts of bringing GECCO to Australia. The other thing you can see, there's a real diversity in terms of the tracks different countries submit to. Yeah, so we see that for the Australian community as well. They obviously were submitting to all of our tracks in the conference, really, which is nice to see. These figures are a little bit outdated, I'm afraid. So these are the registrations numbers from Saturday. As you see, we've since increased our number of registrations. We're now at 666. They were slightly smaller there, but the comparison I'm trying to show is where our participants this year sat in terms of on-site versus online participants. Yeah, and again, we kind of see what we would expect to happen. So we have really, really good attendance from Australia. A lot of participation more locally. And then actually we have quite a large online contingent this year from the European audience, which is fine because GECCO will, I'm sure, come back to Europe again. And so this is only fair, right? That this year it was the Australians who didn't have to travel so far. Although, to be fair, in Australia, even traveling from another city is probably still quite a significant trip. Okay, so that's all I have to say for now. I'm going to come back on the stage later, but at the moment, I'd just like to hand over to the summer school.
Right. How do I go to the next slide? How do I navigate the slides?
Green button.
Okay.
And if you mispress, you go backwards.
Perfect. Okay, so hello everyone. So the SIGEVO Summer School took place again this year, face-to-face. We actually tried something new this year. We had co-located in 3 different locations, not 2, not 1. We had 3 days at co-located with the Optima conference, followed by 1 full day at RMIT. And then we had the workshops and tutorials at GECCO, followed, of course, by the conference itself. So if you're feeling a little bit tired because you've been waking up quite early throughout GECCO, share a thought for the students who have been doing that for 9 days straight. Speaking of the students, you see there a map of their place of work and where they came from. So you see they come a little bit from all over the world. For some strange reason, we had a lot of students from Australia this year. We're still trying to figure out why that happened. We would like to thank quite a few people to help us. The list is not exhaustive, but we had Charlotte at Optima, great help from her. Of course, Xiaodong really to help us with the RMIT location. And from GECCO and SIGEVO, Julia and Marcus helped us a lot. And of course, our mentors, huge thanks to Carlos Fonseca for his hard work throughout quite a few years by now, but also Diederik Vermetten, Manuel Lopez Ibanez, and Jürgen Branke. Apologies for not having put your name on the slide. Share a thought as well for Manuel, who arrived on Saturday at 5:30 in the morning, and at 10 a.m. he was giving his 2-hour workshop at the school. So I will leave you with some photos of the action. You see that we were very, very hard at work, but hopefully a little bit having a bit of fun as well and getting to know each other, which really is what we want to achieve at these SIGEVO summer schools more than anything else. Really getting to know your peers and starting to get to know as well the fantastic community that we have at GECCO and SIGEVO, and hopefully then shaping up collaborations that you're going to have in the future. So if you want your PhD students to share some of the fun, consider sending them to the SIGEVO summer school next year. Thank you.
I was just sitting there saying, if nobody clicks, I don't know who's next. I guess it was me. All right. I will say a few words very quickly about ACM SIGEVO. So I already said some things at the beginning, so I'll be quick. So ACM is the professional organization for most computer scientists, the Association for Computing Machinery. It's about 100,000 members. And about 40 special interest groups, or SIGs, and among them is us, SIGEVO. We have about 500 members, and importantly, SIGEVO volunteers run GECCO and FOGA. So everyone you see up here gets paid $0 for everything we're doing. It's very important, maybe to. So you get, of course, eternal fame, but that's what you have to deal with. And I'm also realizing that I think while, of course, Xiaodong will say goodbye at the end as general chair, and there will be a good moment to applaud him, I think this is also a good moment because he's already thanked everyone else on his team to say, Xiaodong, can you please stand up and we can thank you for having an excellent GECCO here. All right, continue on with SIGEVO. So being a member has certain benefits. So you get free access to the ACM Digital Library. You have a reduced fee at a conference, quarterly newsletter, of course, and you get to be on the mailing list and see all kinds of things. But very importantly, because these things are repeated every year, I added one thing: you're part of something special. So be part of the group. We're all very easy to approach, and this is one way to contribute. So please consider becoming SIGEVO member if you're not already. So as an organization, it was mentioned already, there are some officers there who I communicate with frequently to make sure we do the best we can to keep this thing moving forward. And then there's a business committee there who is mainly in charge of kickstarting future GECCOs. And as said already, Anoje and Manuel are currently in charge of that. So thank everyone there for doing that. Then there's a larger executive board who decides on new things that impact also GECCO. Strategic issues like GECCO policies, 18 members, 6 of them are renewed every second year. And we have an advisory board of former members, which include Ken de Jong, Eric Goodman, Mark Schoenauer, Darryl Whitley, and Wolfgang Banzhaf. And we take great note of their advice in good and bad times. Finances, Marcus tells me continue to look good, so that's what I report. Usually 20K for student travel grants. This year, for the first time, we had a childcare reimbursement scheme, which 2 families I understood were able to make use of. It's new, but maybe who knows, we intend to run it again next year. So maybe more people will use it if we are in a different location. Anyway, I think it's important that we are investing in this as well. In general, as Marcus already, of course, pointed out, we invest in hybrid environment-friendly conferences, and if you have any more ideas, then please let us know. We're always looking to innovate. We have invest in various awards, which you'll soon be subjected to, and hopefully will win one, who knows? And some have a monetary prize, so that's all the things that SIGEVO does, just to let you know. Importantly, I come back very quickly, and I've said this at the beginning, so I'll do it short and at the beginning, but I wanted to make sure that I maximize the chances that everyone has seen this at least once. So ACM Open, importantly, ACM will transition to open access fully, and at least one author must be affiliated with an institute whose library has the ACM Open agreement when this starts in 2026. So again, GECCO next year is not affected by this yet, but the year after, in all likelihood, will be. And if you do not have an ACM Open agreement, every paper will have to be covered by $700 US if you are an ACM or SIGEVO member, and otherwise $1,000 for an article processing charge, and unless your country has an economic or financial waiver. So I said 2026 will be the first conference which this holds, and so this is again my second call to action. If you have not already done so, go to your institute library, get them to talk to ACM, and let me know how it goes. And please fill out the questionnaire that will be sent out by email after this, which will include also questions on this. We would love to know how you feel about this and how you think this will impact you. Please get back to us on that. If you want to know if you're already covered, there's this particular link. So please find that out, and please make sure that this number 666 that I just learned of does not have any further meaning, please. All right. As SIGEVO chair, I also typically say something about GECCO. So GECCO this year was obviously here in Melbourne. Well, next year or so has become quite the normal thing to do. Every other year we are back in Europe. So To be announced where, I said wait till the end because I don't want to say anything, but it will be in Europe. And then we are currently contemplating, so this is not 100% sure, but to be in South Americas in 2026, and then back to Europe in 2027, and completely still more or less open, but the idea is to sort of shift back to Asia then maybe in 2028, but we'll see where we are by the time we get there. If anyone has any ideas about this, feel free to contact the business committee or me about if you feel like I have a great opportunity to host this, let us know. FOGA is the other conference that is part of SIGEVO, so Foundations of Genetic Algorithms. Something will be said about this as well, so I have these quite interesting slides with all the kind of TBAs and TBDs. I'm not really saying anything because someone else will, but it will be in Europe. And as I said, if you have any ideas about how to improve things or where it could be hosted, please contact me or somebody else from the business committee. And that's all I had to say. Thank you very much, but this is not done. We continue now with the ACM SIGEVO Outstanding Contribution Awards. And I'm actually not sure who's presenting this. Was I presenting this? All right, so I'm presenting this. I wasn't sure about that, sorry. Then it's my great pleasure and honor to talk about the Outstanding Contribution Awards. If you want to do this, it's fine by me as well. But there's not a whole lot on the slides, but maybe you should come up here anyway. So I can talk and you can add whatever you want to say. The ACM SIGEVO Outstanding Contribution Award is bestowed annually to a maximum of 2 individuals. This is an award that we have at the ceremony, so it says right there, and it's happening right now. Each award will carry a monetary value of $1,000 and a plaque contributed by SIGEVO, or I think actually a plaque that still needs to be made, but you are on top of it, right?
Yes, I'm on top of that.
Yeah, right. And so we have a committee for that, which is headed by Unime. Right. So I think it would be good if you sort of move over and go ahead.
So one thing I want to say before I reveal who the awards go to this year is that this is an opportunity for any of you to recognize people in the community who don't already have an award and nominate them. It's a very simple nomination process. So if there's someone who meant a lot to you and who you feel has had a real impact in evolutionary computation, bring your nomination to the committee. We'd love to see it. And this year, we were fortunate enough to award 2 different researchers in the field. The first person we're going to give the award to is Dr. Anne Auguet from France. And the award goes to her in recognition of her fundamental and influential research in algorithm foundations of evolutionary computation and of her dedicated service to ACM SIGEVO. You'll remember that she was actually a GECCO chair at one point. So let's congratulate her. Both awardees are not here. They were online attendees of GECCO, so they can't join us right now. We're going to give them their token award plaque or whatever when next year at GECCO. So the second awardee is Franz Rotloff. Give it up for Franz. And Franz is being recognized for his fundamental influential research on solution representations in evolutionary computation, and as well for his extraordinary service to ACM SIGEVO. So give it up for Franz one more time. And I'm going to turn this over to SIGEVOlution, the newsletter. Is that Gabby? Here she goes. There. Excellent. Yep.
Okay, thank you, everyone. So yes, the SIGEVOlution newsletter is a quarterly newsletter, so we have 4 numbers per year: spring, autumn, fall, or spring, summer, autumn, fall, and winter. So this issue we have as a cover the coin, the Portuguese coin, that has also been part of the HUMIS participants. And yes, I mean, I welcome everybody that, especially, for example, PhD students, we can present a summary of your PhD. I saw some people taking pictures, Julia, of your statistics. And normally we also publish a summary of GECCO either in the next issue or in the following issue. So these are the type of things we publish: short surveys, summary of events, summary of dissertations, PhD students, etc. And also, if you are involved in art, evolutionary art, or data visualization, we also like to have like visually appealing covers. So if you want one of these contributions, please get in touch. Thank you. Job market is the next one. So the next is the GECCO job market. Okay.
Yeah, the GECCO job market. I know that everyone is waiting for the upcoming awards, so I hopefully be quick. It's an event taking place since 2017. It's organized by Thea Tushar from JSI in Ljubljana and me. And, well, of course, it's about bringing people offering a job together with these looking for a job. And, yeah, I think we did this quite successfully even this year, although we had only a few open positions, like 10 open positions, which is only half of the ones we had last year, for example. And it was surprising and kind of, unfortunate that the night before the event, so before the job market took place, somehow suddenly there were another 4 institutions showing up on the website that you see down there on the right-hand side. So, yeah, I think it's quite successful, although not too many open positions this year. But we hope to have more next year. By the way, talking about next year, there will be a change in the organizing committee. And if you're interested in the job market and possibly organizing it, then get in contact to me, please. So that's it, all I have to say. And I think we're going for awards next, right?
They have the SIGEVO Best Dissertation Award. This is what we awarded. So this is all the information on the website. But I want to highlight is the deadline. So the deadline is 1st of March every year. So you can start preparing any nominations for any thesis that go to the library in 2024 are eligible for the nomination for 2025. The deadline is after GECCO, but you can after GECCO paper submission, but you can start the preparation now. This year, this is the award committee. So we have went through many rounds of looking at the thesis, and we have finally reached to an agreement. But my committee has led me to say that all the theses are very high quality, and all the 3 top ones are super excellent. You can probably start looking at them. And we have, 2 honorary mention and 1 winner. So the first honorary mention I want to show here is, so the winners, the awardees are not here. We just make announcement. So ACM is now preparing their honorary and also their plaques. And so the first one, the honorary mention goes to Garrett Joseph Bingham for his thesis on optimizing neural networks through activation function discovery and automatic weight initializations. So congratulations. And the second one goes to Christian L. Camacho Venelo for his thesis on design new meta-heuristic implementations from the metaphor to the automatic design. And finally, The winner of this year is Anton Bolter for his work on optimal mixing evolutionary algorithm for large-scale real-valued optimization, including real-world medical applications. This is all from me. Just remember the deadline for nomination is the 1st of March. Thank you. And next one is workshop.
Hello everyone. So first, it's a real blessing to chairing the student workshop at GECCO. It was my first time. I learned a lot. A special thanks to the co-chair, Professor Ying Bi, who is not here. She already left, but she helped me a lot. A special thanks to Julia and Zhedong. We are really fortunate. We received 16 papers, and out of those 16 papers, these 3 papers are shortlisted as for the best paper award. You can see all of them are very excellent point and show the great potential of the next generation of the community. We are happy about the quality, and finally, out of the voting by mentors and reviewers who I cannot thank enough because they really support the students. Finally, the second paper, Evolving Quantum Logic Gate Circuits in Qiskit by Alberto Moraglio and Thomas Newbold, was selected for the Best Paper Award. So join me to congratulate. As you remember, it was the online presentation, so I believe they are not here to receive the plaque. Thank you.
Good afternoon, everyone. It's a pleasure to present the competitions for GECCO. We had a large number of entries. We had 15 proposals initially, and after some review, 14 of them were accepted to run, and one of them had to be cancelled due to some technical reasons on the way. So finally, we had 13 competitions running. These are those competitions, very wide range of very interesting and challenging problems, from benchmark problems to multimodal problems to automated design, control, and so many different types of applications. There were 2 sessions held yesterday for discussing each of these competitions and to do the presentation ceremony. Today, what we want to do is to acknowledge all the winners who are on this slide. And if some of you are here on site, I would invite all of you to come to the stage for a group photo, and also please bring your certificates if you have them with you. Do we have some? Okay.
SIGEVO. No, not, yeah, we are evolving. Fantastic. Thank you.
And I'd just like to thank all the organizers for their hard work in organizing these competition, and all the participants for developing the new methods to solve these challenges. And congratulations to all the winners. Thank you.
All right. Did I find the place to push? No. Where am I? The green. Okay, perfect. All right. Well, thank you very much. I would like to thank you all, so many of you, for attending the Humies competition yesterday. That was a new high attendance record for the Humies, I'm quite certain. So thank you very much for your interest and enthusiasm. I'd like to first introduce the judges for the Humies. Wolfgang Banshoff, Stephanie Forrest. Stephanie's not with us here. Myself, Uname O'Reilly, Lee Spector, who also is not here today, and Daryl Whitley. And our publicity was very well handled by Bill Langdon. He has been tireless in tweeting and getting everything well publicized, and that has been very successful. Our sponsor is John Koza, and John has been providing the prize money for the Humies competition for 21 years now. While we're talking about the prize money, let me just mention to those of you who are the fortunate winners of some of that prize money, Dr. Koza sends the money to the Association for Computing Machinery, not to me. If it were sent to me, I would write you a check. But instead, we have a procedure whereby the ACM will ask you for certain information and to fill out certain forms, and then eventually you will get a bank transfer or something equivalent, okay? So, I mean, I just apologize that it takes a little while and it is completely out of our control. So that's the way it is. Okay, let us continue. This year we received 16 entries, and back in early June, the judges deliberated these entries and narrowed those down to 8 finalists, which is how many we have time to have presenting here. The entries were excellent. 7 of our entrants were here personally and presented live, and 1 was presented via a video. I can't tell you how difficult the judging of the Humies is, because unlike the other competitions where they're all working on the same thing and somebody got it best and somebody got it second best, the Humies are apples and oranges. They're so many different criteria that people can use to qualify for the Humies, and many different types of contributions. So it's extremely difficult, and I will tell you that the judges would have happily given away 6 or 7 or 8 awards this year had we been able to do that. We look at the entry forms, the papers, the presentations, all of those things enter into the judging process. And this year we had, again, after much discussion, we settled on 2 bronze awards and 1 silver award and 1 gold award. And those are as follows. First of all, one of the bronze awards, and the bronze awards are in no particular order. We have I will ask the presenter who did this, David Howard, to come forward for a certificate. And the project was Freeform Generative Design of Complex Functional Structures. What they did is use evolutionary computation to come up with designs for parts of a continuous chemical process system, in particular, that can be used for removing heavy metals from water. And this is something that has a real potential for contribution, and we value that very highly. And a second bronze award goes to the team that did the work on macro placement by wire mask guided black box optimization. We are now putting thousands of macros components on chips, and it is very difficult to figure out where to put them because they not only have different sizes and shapes, but they also have different connectivity requirements. This group is dealing with that in such a way that compared to ordinary benchmarks that are used in this industry, they beat the area requirements by on the order of 50%. So it's a very large improvement in technology. So I'd like to ask Chao Chen to come forward for their award. You see here? All right. Congratulations. And now the silver award goes to the group that entered From Pixels to Metal, AI-empowered numismatic art. Penisal Machado. We'll turn it around that way, yes? There we go. Okay. And what they did is they designed, well, they evolved a design for one side of a coin and then actually documented the design of that coin on the other side, how it was done by AI. And it's a very nice looking coin, and it's a 10 euro coin. That's an official coin. And in the first month that it was available, it sold out. So collectors have highly valued the design of this coin. And as I say, the one side was by AI for humans, and the other side was by humans documenting the AI on the other side. So remarkable achievement. Congratulations. And we come to the Gold Award. This year, the Gold Award goes to the team doing evolutionary design of explainable algorithms for biomedical image segmentation. And the representative who presented that was Dennis Wilson. Congratulations. That team is able to do things more effectively than radiologists are doing them in examples where they are picking out cell boundaries and being able to do that with very good accuracy. And it's certainly human competitive. So we congratulate them on their contribution that could have some real world contribution to future diagnostic capabilities. So congratulations to that team. I would like to just say that for next year, we will be running a Humies competition again, and I hope that many of you will take the work that you've done between now and June 1st of next year, anything that's published in between there, and that also includes, by the way, things accepted for next year's GECCO, and submit those to the Humies competition. And thank you.
Okay, so we're coming to the most important award of the day. Outstanding Reviewers Award that was introduced last year for the first time. It's arguably the award that should matter the most because these are people who give up their time for the benefits of all of us. And they're doing so with very, very little recognition. Just to give you an idea of the scale of the work that our reviewers put into ensuring the scientific quality of GECCO. So for this GECCO, we had 1,870 reviews of full paper submissions, an additional 93 reviews of poster submissions, and 357 reviews for workshops. As you can also see from this, so this is a breakup in this chart actually of average review lengths by track. Yeah, so obviously length of a review is only one indication of the quality of a review. It could be ChatGPT generated and very long, that doesn't make it good. So this is only one proxy measure of showing you the effort that people put into their reviews. But one of the things you can see from there is that we have some people who obviously put an enormous amount of work into this. And then we also have some people who maybe don't quite do enough in terms of making sure that they actually justify and explain to authors why their paper is being downgraded to a poster or being rejected. So that's a call of action really for everyone to try and do that a little bit better, and imagine that you find yourselves on the receiving end of the reviews that you're writing. So we've been very, very selective in terms of selecting outstanding reviews this year so that I could fit them on a single slide. But also to make sure that actually receiving this reward is really something special, they're really recognizing those reviewers that really wowed our track chairs. So I have managed to fit them on one slide. This is the list of our outstanding reviewers this year. One of the amazing things about this list is that this list includes everyone from PhD students all the way to professors, right? So just because of the stage you're in at your career stage, that does not mean you can't produce a high quality review that really helps the track chairs in making the right decisions about papers. So a lot of these reviewers are not actually on site. A few of them are. A few of them have managed to join us online. We're not giving out the certificates today. I'll be sending those by email, but if I could ask everyone who is here to come on stage for a group photo, and if I could ask all of you to give them a really big hand.
Very, very good. Oh. There we go. Beautiful. Good work. Thank you.
So, which brings me to the other award that I have the pleasure of announcing, which are our Best Paper Awards. The first Best Paper decision was a joint, it was an award for two smaller tracks that share an award. So there was a competition between a paper from the Complex Systems track and the New Learning for Evolutionary Computation track. And so the votes from our participants decided that the best paper on this joint competition is Quality with Just Enough Diversity in Evolutionary Policy Search. I believe the track chair for Complex Systems, Emily, is also here, so if I could ask you on stage, and Sheldon, you can join us as well. Over here. Oh, and
Thank you.
So the next set of nominations were the three papers put forward by the track chair on the econ track. And so the winning paper on that track is Letting a Large Neighborhood Search for an Electric Dial-a-Ride Problem 5. Okay, so another big track, the evolutionary machine learning track. That was our second biggest track this year, and so they got to put forward 3 papers for best paper nomination. These are the 3 nominees, and the winning paper on that track is Survival LCS, a rule-based machine learning approach to survival analysis. Okay, another big track, evolutionary multi-objective optimization. Again, 3 papers that reviewers and track chairs identified as outstanding on that track. And the winner on that track is this first paper, Analysis of Real-World Constraint Multi-Objective Problems. Another shared award, so this is between the ENIM track and the Swarm Intelligence track, and the winning paper between those 2 is the Swarm Intelligence track with Markov chain-based optimization time analysis of bivalent and collinear optimization for sorting and leading ones. Okay, another joint award. So this is genetic algorithms track joined with the theory track. We had 2 papers, 1 from each track, and the winning paper was Evolutionary Computation Meets Graph Drawing, Runtime Analysis for Crossing Minimization on Layered Graph Drawings from the theory track. Joint best paper nominations between the genetic evolutionary computation and hybrids track and the neuroevolution track. We had 2 papers and the winner between those 2 tracks was tensorized neuroevolution of augmenting topologies for GPU acceleration. Okay, that brings us to the genetic programming track. We had 2 separate best paper nominations on that track, and the winning paper, there we go. The winning paper is Learning Traffic Signal Controlling via Genetic Programming. And the last Best Paper award for GECCO 2024 was from the Real World Applications track. So on that we had 2 competing papers, and the paper that you all voted for is Quality Diversity Approaches for Time Use Optimization to Improve Health Outcomes. Sorry. Yeah, so the next short section of the session is just a couple of announcements we've got about upcoming conferences.
Hi. So this announcement is about FOGA. FOGA is coming to Leiden next year. The dates have already been decided. It would be 27th to 29th of August. It would be organized by me, Thomas Beck, Francisco Chicano, Jonathan Fildsand, Nikki van Stein, Carola Doyer, and Elena Raponi. We are all waiting for you in Leiden. In case you don't know where it is in Europe. And more specifically, it is in the Netherlands. It's very conveniently located. And as you can see, it's a very beautiful city. You can enjoy the city, you can enjoy the university. So please come. If you think that this announcement is not for you, because you are used to the idea that FOGA is only for theoretical results, please rethink this. FOGA is trying to open itself to empirical analysis as well. So studies on empirical analysis are most welcome. Theoretical studies, rigorous mathematical results are still welcome too. The deadline submission will be in the beginning of May. Registration costs would be similar to what happened in FOGA 23. The format of the conference will remain the same. There would be posters, there would be keynotes, and lots of time to discuss, and our proceedings would be in ACM. The conference will take place in the new building of Leiden University, which is fantastic, and I invite you to come and visit us and walk through the beautiful city of Leiden.
All right, so if you have enjoyed your time at GECCO and in Australia, but wish it was just a little bit warmer, I have the proposal for you. So we have the conference on evolutionary multi-objective optimization. So all of you working on problems that have conflicting criteria to optimize, whether we are working in evolutionary techniques or also multi-criteria decision-making and their applications, you are most welcome to join the conference next year in March, 4th to 7 March. In Canberra, which is short flight from here, maybe a long flight from some other places. Yeah, but we have the top people working in the EMO field committed to joining us, giving keynotes, talks, etc. So we invite not only international community. We'll make it worth your while to come again, but also all the local people who may not have ordinarily had chance to attend EMO because normally it's in Europe or US, to join us next year to expand the community and to have great discussions on the topic. Thank you.
Hello, so I have a couple of species announcements. Let me try to be quick. The first concerns the Julian Francis Miller Award. We give this award every year in memory of Julian Francis Miller. This year the winners were Dario Floriano and Odd Lipson for their amazing work on evolutionary robotics. And there is a nomination deadline until the 31st of July. You can all nominate somebody that you believe deserves this award. Then there is a jury with Unime, Wolfgang, and many others to select the nominations. Also, Species promotes evolutionary computation, and one of the things that we do is award scholarships. So, if you are a host institution, too late, you can apply next year, but please keep this in mind. It's a great opportunity to receive amazing students. If you are a student, I heard that you can still apply, although the deadline has already passed. So be quick, okay? We also organize a summer school. Some of you that I see in the crowd have been there. The summer school is in Spain, in this terrible location in Murcia. You know, there's the sea and hot and so on. This will take place from the 26th to the 1st of September. Registrations are still open. So once again, feel free to go, send your students. They will learn a lot and also get a tan. At least I did. So last but not least, it's my pleasure to announce the EvoStar events. This year, EvoStar will take place in Trieste. We have an amazing local team. Some of them are here. Hello, Georgia, I see you. Hi, Gloria. And EvoStar is an European event, but really welcomes participation for all over the world. We have 4 key conferences and some special sessions: EuroGP, Evo Applications, EvoCop, and Evo Mozart. So please join us at Trieste. You are more than welcome. Okay? Bye-bye. Thank you.
Okay, so we're close to saying our goodbyes. Before we do that, we have one last announcement that we don't have a slide for. So we were made aware that someone is celebrating their birthday today. A 33rd birthday of Mehmet Akbay from the AI Institute of Barcelona. Where is he? You don't want to hear me sing, so I'm not going to.
Well, the final moment has come, so we'll finish the conference. I really just want to say thank you so much for attending GECCO 2024. I hope you have a wonderful time for the rest of the time here in Australia, Melbourne, right? So I'm going to take a few days of rest, perhaps, yeah. But I really hope you have a fantastic time here. Thank you so much. Yeah. There's a photo here. You could from last night, yeah. So the next one, I think we're going to invite GECCO 2025 General Chair. Yeah, Paul, can you come up? Yeah.
Okay, thank you. So I am Bogdan Filipic. I'm here to announce the GECCO 2025. So I wish to start by saying that, as you all know, evolutionary algorithms are stochastic and randomized, but they usually work very well. So I want to say that GECCO 2025 will be held in Europe. And we count on a bit of your patience because the location has not yet been finalized. In close collaboration with Business Committee and SIGEVO board, we are considering several options, and we will soon let you know where the conference will take place. Now, there's an enthusiastic team has started forming. So Gabriela will be editor-in-chief, and I'm very grateful for her to accept this role. I will be the general chair, and we already contacted some of you to help us in organizing the event. Thank you all to those that said yes. We count on many more in the future. So the timeline will be similar to those we had for past events. It will be the announcement of the calls for proposals for tutorials, workshop competitions, and then the notifications. Then it will be this usual submission of abstracts towards the end of January, paper submission a week later on, and then acceptance, and the conference at the usual time, mid-July. As you can imagine, this is closely related to selecting the venue, so the precise dates will be announced. You will be informed through this usual media, so there will be website and announcement of all the information on social networks. So with this being said, after a short rest, please start preparing your best papers, and of course, please send them to our conference, and I hope to see you and many more others next year in Europe. Thank you very much.